Hello everybody and welcome to this version of distributed systems straight from my office to your desktops. Now I've had a large amount of people either write to me or come to my office to discuss about testing. So I thought that maybe I'll just make a little video on testing 101. And in this very quick video we're going to talk about how we would test any program, usually any distributed systems, but in particular a Java program. So let's say you have this program and usually it runs with an input, it has an output. Now what most of you have been doing so far is in this program you've written, let's say, I don't know, stub dot push, you've pushed maybe a value 4 on the stack, you've pushed another value 2, let's say, on the stack, you probably pushed an operator, let's say multiplication, and then you printed out the result, pop. And you've looked at the result with your eyes and using only the power of your brain said, oh, okay, well, if I pushed 4, 2 and multiply on the stack, then the result should have been 8. Now, if the result is 8, then you're happy. If it's not, so if it's not printed out as 8 at the prompt, you're not happy. The problem with this is that these tests that you run in which you print out the results, you look at the output and so on, they are not easily repeatable, and in large cases where you have a large number of tests or even more complex mathematics like, let's say, integrals and so on, they're not so easy to calculate, and it's not easy for you to determine whether or not what you have is correct. So in order to get rid of this, what we do when we do testing, large number of markers. Okay, so when we do testing, we surround this program with a testing harness, and I'm going to talk later about how this can be done in Java. And what this basically does is it takes an input here, and for this input, for each kind of class of inputs, is going to take an expected output. And what it will do is, for each of these inputs, it will tie in this input to this input for the program, run the program with the input that is given, and then capture the output of the program in some way. So this is basically the output of the program. Now, it will take the expected output here, so this is the expected output, I'll write it as EO, and then compare between the expected output with the output that the program has put. So if the expected output is equal with the output that the program has spat out, then we're going to say happiness. So sorry, if it's equal, then it's going to be yay. If it's not equal, then it's going to be, I don't know, doom. So what this means in our case for the 4 and 2 is the input that we're going to have is going to be 2, 4, and multiplication. This one will be put here, 2, 4, and multiply. The expected output for 2, 4, and multiply is 8. So what we're going to do is we're going to feed this into our Java program, capture the output, and compare that output with 8. If it's equal, then we're happy. If it's not equal, then of course we're not happy. This can be in your Java program just as simple if pop is, let's say, equal to expected value, whatever that one is, then system out println yay. Otherwise, oh, sorry. sorry, in A. Now, what is important, and this is basically the first stage of testing, is to get this part right. So you need to compare the results of your operations with the expected results. The next stage will be to how, for example, for a distributed system, how you run multiple clients at the same time, or and then how you compare the output of your program with whatever it is that you have expected as an output. But we're going to deal with that in the first collab session. Okay, cool, that's me.